What if the glowing curtains of light in the night sky weren't just a natural wonder, but messages from the gods or warnings of war? The northern lights have fascinated humanity for centuries, today forecasted with science, but once feared as omens or spirits dancing above. In this journey, we'll explore both the modern forecasts and the ancient myths. Imagine standing under a frozen Arctic sky, when suddenly the darkness comes alive. Ribbons of green, streaks of purple, even flashes of deep crimson, swirling overhead. These are the northern lights, or more scientifically, auroras. Nature's own light show, born from a cosmic dance between the sun and earth. It all begins 93 million miles away. The sun constantly sends out streams of charged particles, known as the solar wind. Most of the time, Earth's magnetic field shields us, like an invisible force field. But when those particles sneak in near the poles, they collide with atoms in our upper atmosphere. The result? Explosions of light that ripple and twist into dazzling forms. That's why auroras appear mostly in the polar regions. Aurora Borealis in the north, Aurora Australis in the south. And no two displays are the same. Sometimes they stretch into arcs across the horizon. Sometimes they fall like curtains of light, and at rare moments they burst into spirals or explode into a corona that feels like the heavens opening above you. The colors themselves are clues to what's happening high above. Green, the most common, comes from oxygen about 60 miles up. Higher still, oxygen can glow deep red, rare and eerie. Nitrogen, on the other hand, paints the skies blue or purple. It's like the atmosphere is its own artist, using chemistry as a palette. And the question people always ask is simple. Are these lights just science or something more mysterious? Imagine the sun not just as a glowing ball of light, but as a restless giant, constantly throwing tantrums. These tantrums come in the form of solar winds, streams of charged particles racing through space. Sometimes the sun even hurls massive eruptions, called coronal mass ejections, carrying billions of tons of plasma outward. Now, where do these storms end up? Right at our tiny blue planet's doorstep. Thankfully, Earth isn't defenseless. Wrapped around us is the magnetosphere, an invisible shield shaped by Earth's magnetic field. Think of it as a cosmic umbrella, deflecting most of the sun's particles. But like any umbrella in a storm, some rain still sneaks through. At the poles, where Earth's magnetic field lines dip down, these solar particles funnel in, colliding with gases in our atmosphere. The result? Brilliant curtains of light paint the night sky.
But why do we see auroras more often at certain times? That's where the sun's mood swings come in. Every 11 years, the sun goes through what scientists call the solar cycle. At its peak, known as the solar maximum, the sun is more active, with countless sunspots, flares and eruptions sending a storm of particles into space. During this period, auroras become more frequent, more vivid, and sometimes even visible farther south than usual. It's almost as if Earth and the sun are locked in a rhythm, a cosmic dance repeating every decade or so. And that leaves us wondering, what might the next solar maximum bring to our skies? Imagine standing outside on a freezing night, eyes fixed on the dark sky, wondering, will the lights appear tonight? That's where forecasting comes in, a fascinating blend of space science and a little bit of guesswork. Agencies like NOAA's Space Weather Prediction Center in the US and the European Space Agency in Europe have teams of scientists who spend their days studying the sun, trying to predict when it might send streams of charged particles our way. The sun may look calm from Earth, but in reality it's anything but quiet. It's constantly releasing a stream of charged particles known as the solar wind, flowing outward across the solar system. Most days, this wind is gentle and harmless, but sometimes the sun erupts with violent outbursts. These explosions, called coronal mass ejections, or bursts, from highly active sunspots, send billions of tons of charged particles racing through space at incredible speeds. When these streams head toward Earth, they typically take about 2 to 3 days to arrive, and that's when the real show begins. As the particles collide with Earth's magnetic field, they stir up geomagnetic storms, fuel for the spectacular northern and southern lights. The stronger the solar storm, the more vivid and far-reaching the auroras become, sometimes even dipping into regions far from the poles. To measure this solar drama, scientists use something called the KP index. Think of it as an aurora forecast scale ranging from 0 to 9, A reading of 0 means calm, quiet skies, but when the KP climbs to 5 or higher, that's aurora alert territory. In other words, the sky might just be gearing up to paint itself in waves of green, purple and red. But forecasting isn't just about the big picture. There are short-term predictions, which look hours ahead by measuring solar wind data from satellites parked in space. Then there are long-term forecasts based on the sun's activity cycles and patterns. These give us a sense of when aurora seasons might be particularly exciting, though not the exact nights. For everyday sky watchers, the science has been made accessible. There are aurora forecast apps, space weather dashboards, and even text alerts that ping your phone if there's a high chance of activity in your area. How cool is it that you can get a heads up when the sky might burst into color?
And yet, the northern lights love to keep a little mystery. Even with advanced satellites and data, auroras can appear unexpectedly or fail to show up when forecasts look promising. Clouds, local weather, or sudden changes in solar wind speed can throw predictions off. It's a reminder that while humans can measure, calculate, and predict, nature still writes the final script. So, the next time you're under a starry night sky waiting for the aurora, ask yourself, will tonight be the night the sky dances? If you've ever dreamed of standing under a sky that looks like it's been painted with liquid fire, you'll need to know where to go. The northern lights don't show up everywhere. They have their favorite stages: Norway, Finland, Iceland, Sweden, Canada, and Alaska. Those are the headliners. These regions sit comfortably under the auroral oval, the zone around Earth's poles where lights are most active. Travelers from all over the world flock there, chasing that perfect green and purple curtain across the night sky. But every now and then, the auroras like to surprise us. Imagine walking through Scotland or catching a late drive in the northern US, only to glance up and see faint, shimmering arcs. These rare sightings happen when solar storms are particularly strong, pushing the auroral oval farther south than usual. Wouldn't it feel like stumbling upon a secret show that wasn't even on the tour schedule? Of course, not all auroras belong to the north. The southern hemisphere gets its own magical display. The Aurora Australis, down in Antarctica, Tasmania and New Zealand, the lights appear just as vivid, though fewer people get to see them, simply because fewer live in those regions. Timing, however, is just as important as geography. Long winter nights in the Arctic mean hours upon hours of darkness, creating the perfect backdrop for auroras to dance. But summer? Forget it. With the midnight sun blazing through, the northern sky never really goes dark, no matter how strong the auroras are. That's why locals often say, if you want to see the lights, follow the darkness. So here's the big question. Would you travel to the freezing edges of the earth just to catch a sky on fire? Imagine a Viking longship cutting through icy waters, its crew staring up at the night sky. Suddenly, the heavens shimmer with waves of green and red. To them, this wasn't just a beautiful show, it was a battlefield above. The Vikings believed the lights were reflections from the shining armor of the Valkyries, the warrior maidens of Odin. Each flicker in the sky could be a Valkyrie guiding a fallen hero toward Valhalla, the great hall of the slain. For a Viking, this wasn't just a story, it was hope. But not every northern culture saw the aurora as a call to war. The Sami people, who lived even closer to the Arctic Circle, treated the lights with deep reverence. To them, the aurora was sacred, a bridge between the human world and powerful spirits. They believed whistling at the lights could summon those spirits, sometimes with dangerous consequences. So, while the Vikings might have shouted proudly at the sky, the Sami stood silent, awed and cautious. Two cultures, the same glowing sky, yet such different meanings. Was the aurora a warrior's promise, or a warning to stay humble before forces greater than ourselves? Now imagine traveling across the frozen expanse of the Arctic, where Inuit families huddle in igloos under skies bursting with auroras. For them, the lights carried a different message. They were the spirits of animals, whales, seals, even deer, dancing in the heavens. Each streak of color was more than a spectacle. It was a reminder that nature itself was alive, watching, and forever connected to human life. Meanwhile, the Cree people had their own vivid tale. They believed the auroras were the spirits of ancestors, gathered in the night sky to play a great cosmic game of ball. But here's the twist. The ball wasn't a ball at all, but the skull of a walrus. To the Cree, every shimmering arc was laughter and movement from the afterlife. their loved ones reminding them that death wasn't an end, but a continuation. Picture standing there, hearing these stories passed down by firelight, then looking up to see the exact same lights we see today. Would you see dancing animals, warriors or ancestors at play? Or would you, like so many before you, wonder if the aurora is more than just science, maybe even a message written across the night sky? In the east, the auroras were painted in the sky as great battles of mythical creatures. In China, people looked up and saw celestial dragons twisting and clashing, their fiery breath lighting the heavens. The glowing streaks were not just colors, but the very pulse of these mighty beasts. In Japan, the lights carried a softer touch. There, families whispered that children conceived beneath the shimmering sky would inherit good fortune and strong spirits. It was as though the heavens themselves were blessing the next generation with strength, health, and destiny. Can you picture how a single night beneath glowing skies could shape an entire life story?
In medieval Europe, the northern lights were anything but comforting. When the fiery streaks tore across the sky, people feared the disaster was near. War, famine, or plague, such events were often linked to the dancing flames above. Red auroras, in particular, struck terror, for they seemed to paint the heavens in blood. Priests and villagers alike looked upon the sky with trembling, wondering what curse was about to unfold. For them, the aurora was not beauty, it was a warning, a divine message no one could ignore. Isn't it fascinating how the same lights that inspired hope in some cultures stirred fear in others? Far across the seas, the Maori of New Zealand looked upon the auroras with reverence. They called them Tahu Nui Arangi, believing these lights were their ancestors, guiding the living and watching from beyond. To them, the glow was a bridge between past and present, a sign that no one ever truly walked alone. In the Mediterranean, however, the ancients gave the lights another face. The Greeks saw the goddess Aurora, sprinting across the early morning sky, announcing the arrival of dawn with her radiant chariot. For the Romans, the spectacle was no less divine. Auroras symbolized the power of the gods, the renewal of light, and the eternal presence of the heavens over mortal affairs. How could one phenomenon carry such different meanings, from guiding ancestors to warring dragons, from omens of doom to blessings of life? In February 1938, the skies over Europe glowed with a deep crimson light, so bright that people thought entire cities were on fire. In London, some rushed to call the fire brigade, while in Rome, many whispered it was a sign of war. Only a year later, World War II broke out, so can you blame them for thinking the heavens were warning them? That single night remains etched as one of history's eeriest coincidences. Decades earlier, in 1859, the world witnessed something even stranger, the Carrington event. A solar storm so powerful lit up auroras across the globe, from the Caribbean to Rome. Telegraph operators reported sparks leaping from their machines, papers catching fire, and systems working even when unplugged. It felt like the Earth itself had been wired into some mysterious cosmic circuit. But 1770 brought another spectacle, an unbroken blood-red aurora that lingered for 9 nights across Japan and China. Travelers wrote that the skies looked like endless flames swallowing the horizon. Explorers at sea often mistook auroras for city lights or burning towns, chasing them for days before realizing the fires danced in the heavens. Were these dazzling shows nature's warning signals, or simply cosmic wonders humans weren't ready to understand? In today's world, the aurora isn't just a natural wonder. It's also a booming business. Every winter, travelers flock to the Arctic Circle, hoping to catch a glimpse of the glowing curtains of green and pink. From glass igloos in Finland to snowy treks in Alaska, aurora hunting has become a once-in-a-lifetime experience for many. But isn't it funny how something that once terrified entire civilizations is now the star attraction of vacation packages? Artists, too, can't resist the lure of the northern lights. Painters have splashed its shifting hues across canvas, poets have described it as heaven's fire, and filmmakers often use it as a backdrop for mystery or romance. Each culture finds its own way of capturing the aurora's fleeting magic, turning a scientific phenomenon into an endless source of imagination. Yet even with all our technology, the aurora still feels untouchable. Scientists may explain it as solar particles colliding with Earth's magnetic field, but to most of us, it's still pure wonder. Maybe that's why it continues to symbolize nature's raw power, a reminder that some things remain beyond human control. And honestly, when was the last time you stood under a night sky and felt that small, yet that amazed? The northern lights have always carried an air of mystery, but what if we could predict them with the same confidence we predict tomorrow's weather?
That's the future scientists are working toward. Thanks to artificial intelligence and machine learning, forecasting auroras is becoming sharper and more precise. Imagine knowing not just the night, but the very hour when the sky above you will start to glow. Wouldn't that change how we chase the lights? Satellites orbiting Earth now keep constant watch over solar storms, sending real-time data about eruptions on the Sun. These updates feed directly into advanced models that calculate when streams of charged particles will reach our planet and ignite the auroras. This is no longer just for curious stargazers. It's vital for protecting astronauts, satellites, and even the power grids that keep our cities alive. In a way, aurora forecasting has evolved from mystical guesswork to cutting-edge science. What once was seen as a sign from the gods is now monitored with precision instruments circling the Earth. The lights remain magical, yes, but behind them lies a growing science, one that protects us while still keeping the wonder alive. The northern lights sit at a fascinating crossroads, half ruled by science, half bathed in mystery. On one side, satellites and algorithms now tell us when and where the sky will shimmer. On the other hand, old myths of dragons, spirits, and warriors still whisper through the colors. Isn't it strange how even in an age of data, we still crave a little magic? This duality makes the aurora timeless. You can plan a trip months ahead, follow real-time forecasts, and almost guarantee a glimpse. Yet, no chart or model can capture the feeling of standing under a living, breathing sky that has inspired humans for centuries. And maybe that's the point. Whether you see warriors, dragons, or just charged particles, the northern lights remind us that the sky has always been humanity's greatest storyteller. And that's all about it. If you like this video, please give a thumbs up, and if you like more updates, subscribe to our channel. Don't forget to click on the bell icon so you don't miss any videos and get notifications on time. Don't hesitate to give suggestions for our videos. See you at the next one.